Hello guys, this is a solenoid. This is also a solenoid, and I'm gonna show you what that means. It means they're scamming you. See, this cost like 60 euro, something like that. I know this costs $5. $5. You can use it to make an engine. Whoa, look at that engine. And it can shoot. That's cool, right? All of this, like 10 euro. I'm gonna show you how they're scamming you, the awful HPA companies. Look at that. Anyways, so two main functions of an airsoft engine. It must reciprocate the nozzle and it must shoot air. So here's a printed version of the Pulsar. It doesn't look like one, but it behaves exactly the same. Open bolt engine like this works is that the nozzle goes forward, and once this O-ring no longer seals inside the cavity, air can go through the nozzle. To do that, you need to push the nozzle somehow, and for that you can either use mechanical valves or you can use a solenoid. If you look closely, you can see there is actually two little holes. The top one is the middle one here, and the center one is the large one here. The channel from the upper hole right here is always pressurized. As air comes in to the engine, it is always pressurized, and it pushes against the plunger that is threaded in. It pushes against the spring, but it's too weak. So what the solenoid actually does is pull back the plunger to block off this vent and to allow pressurized air into this chamber so that it can push against the back of the poppet. Since this area is much larger than the area that's exposed up front, it forces the nozzle to actually go forward. Once the nozzle is forward, this O-ring pops out like this, and air can actually pass through the little holes and shoot out. When you're done shooting and you deactivate the solenoid, the plunger actually goes forward again and no longer allows air into the channel. And when the plunger goes forward, it no longer seals against the hole and air can actually leave. That's the absolute most basic engine. Air goes in, it pushes against the plunger, you activate the solenoid, you pull back the plunger, you allow air to go into the cavity and push against the back of the poppet, which has a larger surface area than on the front, which is always pressurized. Nozzle goes forward, air is allowed in through the holes in the poppet / nozzle, and when you deactivate the solenoid, the plunger goes forward, air from the cavity can escape through the front, and then the force of the air pushing on the front of the poppet is enough to return it to the back, and you're ready for another shot. That's all there is to a Pulsar. So you may think, why the hell did they cost so much? Well, because you pay for it, you fucking retard. So to make an engine like this, you absolutely have to have resin printer. And you can apply absolutely the same principles to make your own engines. So here's a radically different engine that is also single solenoid. And this in fact is the engine that I showed you in the very beginning. I will not elaborate too much on how it works, but it's a very different design. And the whole point of it is that it has a very rigid very rigid nozzle. For an open bolt engine, it's not going anywhere. Unlike the Pulsar, which it's a bit loose. It's very small. In fact, it could be made smaller, but I don't want to sacrifice on durability. As well, it has a lower nozzle force, so it doesn't force the BB as much. This actually may be a bit of a negative for printed engines, because the friction of O-rings against the resin is much higher than against well-machined aluminum. So this engine has to be tuned quite well to work well, but it's pretty good. But we all know that open bolt single solenoid engines are a bit shitty. Well, one of the most popular engines is the Inferno, and you can actually make something like that too, with a spring-loaded nozzle. This is an engine that's similar to the Inferno, but it doesn't use a high-flow solenoid. It still utilizes a small little hole right here. So you can see, unlike the previous engines, there's a little bit more to it. It has a spring just like the Inferno, and it has a two-part nozzle and poppet assembly. I'm not gonna tell you too much about this engine, because there's a bit to talk about. But you can see that the poppet is a bit more like the Pulsar copy, and that is the crucial difference between it and the Inferno. This engine works exactly the same way like the Pulsar. It has a solenoid that's pretty much the same. Air goes through these little holes on the side into the chamber, into this chamber. In the chamber is the poppet, which at rest is at the very back. When air can go through, it actually pushes the poppet forward until the holes come out and air can actually go through. How a hybrid engine works: end of the poppet's travel, the nozzle actually has already reached its end position, which is like this. The poppet actually opens to air after the nozzle has already gone forward and rested there for a short amount of time. There's benefits to accuracy, there's benefits to feeding. It's more consistent because the nozzle force is always the same, and no matter what pressure you use, it's always just the force of the spring. And I actually used a brass insert so that the poppet can move more easily in there. Next, we can talk about how to make a mechanical engine. And in a way, this engine is similar to the hybrid engine I showed before, because this engine has the same kind of nozzle and poppet setup. However, you may see that there is just a single O-ring, and the reason behind that is that the air that's pushing the poppet forward is actually also being used as the air that goes through the nozzle. This part is basically the core of the engine, and it behaves exactly like a QAV valve. When air goes through here, it actually pushes past this rubber bung, pushes past, and it pressurizes the entire shell. So the whole shell is full of pressurized air. And when the air goes through here and pushes it forward, you can see the central rubber part actually has a ring on it, has sort of ring of lubricant and whatever on it, and that's actually because it rests against this part. And as it rests against this part, it seals it and it allows air into the chamber. So as air is going in, the chamber fills up. The chamber fills up and it pushes the poppet back. And along comes the nozzle. And by default, the engine just stays like this. So how you shoot it is you actually vent the air behind that rubber bung. So you vent the input. You can do this with a simple trigger valve like this. You can use a valve like this. It has an input, it has an output, and it has vent holes. So when you press the button, you allow air through here into the engine. The engine fills up with air. The nozzle and poppet assembly goes back, and it is ready to shoot. It can load a BB. When you actually release the button, the entry point is blocked off, so the air from your regulator cannot actually go anywhere. And then the pipe that was actually going to your engine is vented through these little holes. And what that actually means is that in your engine is pressurized air, and the input was vented. So there's quite a large force coming from the pressurized air in your engine against this bung, which actually seals in one direction. It only seals when air is pushing there. So air pushes it back. The input is sealed off, so any air that is already in the shell cannot actually exit through there. And as the bung goes back, it actually opens this hole, which allows the poppet to go forward and past this O-ring, and past the little O-ring. Once it passes the O-ring, all the air from the shell can actually go through this hole, and through the nozzle. And that's the whole shot. So I've told you a bunch of random crap about airsoft engines. I really had to get this off my chest. I couldn't bring myself to make this video for months now. I wanted to do something bigger, but I just want to release this to you guys. Yeah, these prints are like from months ago. Well, if this gets a good reception, I'll make a video, maybe several, on how exactly to make these, and I'll release the files. I will release the HPA files, and you guys can use the HPA files to make engine for yourself. Maybe move on from the Kuba engines for once. They're really not good. They're just not good. If you can make a proper engine like this, it will serve you much better. So during my HPA escapades, I've tried a lot of different armatures. I've done a lot of variants and shit, you know. But in the end, I've got to thank the big boss, the scalar boss, Remy Claudel. Without him, I would have given up. If you guys want an engine like the Wolf, yes, the Wolf that costs like 800 euro, whatever, this cost me $250. I modified it. Don't mind this part. This was the actual end bits. You can actually get the Wolf for $250 from him. $250 with electronics. In fact, the electronics were the ones that I used in the demo.